Hello, as you already know, in this part of the course, we're going to be studying the system SL, short for sentential logic. We've already had a first encounter with the main elements of SL, namely sentences and connectives. And we've seen that you can have atomic sentences and compound sentences, and that to every sentence there corresponds a truth table. Well, in this video, we're going to give a more rigorous characterization of those elements. In particular, we're going to have a formal definition of the notion of an SL sentence. Knowing what counts as an L sentence and having a clear and unambiguous definition in mind is very useful, for various reasons. First, it'll help you avoid quite a few errors down the road. Second, it's going to be indispensable if you decide to follow more advanced courses in logic, in which the object of study is the properties of the system SL itself. Third, it is good for training your mind to try to think about any subject matter in a rigorous way. So even if you already have a vague notion about something, it's always a good exercise to try to formulate it in a more disciplined or regimented way. Okay, in this section we're going to define a formal language, which we're going to call SL. Just like a natural language, a formal language has a vocabulary with a bunch of basic items and a set of rules for putting these items together to form sentences, which is something like a grammar. Let's begin with the vocabulary. These are the basic items out of which everything else is going to be built. All SL sentences are going to be formed out of these elementary ingredients, and nothing else is permitted. The first element in the vocabulary is the sentence letters. Every capital letter, A, B, C, etc., is a sentence letter. A sentence letter by itself is an atomic sentence. But notice that we are not limited to the set of 26 letters from A to Z. If for some reason we run out of letters, we can start another list with a subindex 1. So we can go A1 to Z1. And if we run out of letters in this list, we can start a new one, A2 to Z2, and so on. You can add as many subindices as there are positive integers, so the list of possible sentence letters in SL is endless. In this course, however, we're never going to use the subindices, because we only need a few letters at a time. So the second element is a list of connectives. So far we have introduced 3, the tilde, the ampersand, and the V. But later we'll add 2 more. The third basic element is the parentheses, one for opening and one for closing. So that's it. Those are the basic components that are allowed in the language we're building. Okay, now for the actual rules of the language. These are what we call the formation rules, and they are, as it were, instructions for putting the basic elements together and proceeding further to larger sentences. In giving these rules, we're going to be implicitly defining the notion of an SL sentence. The particular definition that we'll be working with here corresponds to the one given by Teller on page 16. Another thing, our description is going to be general, so we're not going to be talking about this or that particular sentence. Rather, we're going to be talking about SL sentences in general. And how can we achieve this generality? By describing things in terms of variables. Remember that X, Y, etc. are variables ranging over sentences. We could put any sentence in place of X, any sentence in place of Y, and so on. So here we go. The first clause is the following. Every sentence letter is an SL sentence. Remember that sentence letters are uppercase letters from the alphabet. So any of these letters, with or without index, is going to count as a sentence. Notice that each sentence letter counts as an atomic sentence, so that these give us a definition of an atomic sentence in SL. The rest of the clauses involve the connectives, so they implicitly define the notion of a compound sentence. In fact, there is one clause for each of the connectives we've introduced so far. The second one says that if X is a sentence, then the result of attaching a tilde immediately to the left of it and enclosing the whole expression in parentheses is also a sentence. For example, if C is a sentence, and we already know that it is a sentence because it is a sentence letter, then tilde C in parentheses is also a sentence. Moreover, if C ampersand B in parentheses is a sentence, then not C ampersand B is also a sentence. Remember that the negation sign always applies to the shortest full sentence following it, and for this reason, the parentheses are essential for the tilde to apply to the whole conjunction. The second rule is devoted to the ampersand. It says that if X and Y are sentences, then so is the result of placing an ampersand between them and surrounding the whole in parentheses. Within this whole, X and Y are called conjuncts. So if C and D are sentences, then C ampersand D in parentheses is a sentence. And since we know that C and C ampersand D are both sentences, then we know that C ampersand C and D is also a sentence, and so on. The last rule corresponds to the V. It says that if X and Y are sentences, then so is the result of placing a V between them and surrounding the whole in parentheses. Within this whole, X and Y are called disjuncts. So if E and F are sentences, then E, V, F in parentheses is a sentence. And since we know that E and C ampersand D are both sentences, then we know that E, V, C, and D, with the parentheses in place always, is also a sentence, and so on. Finally, our fourth clause tells us that nothing else counts as an SL sentence. And this is provisional, because we'll add more symbols in future lessons. Notice that in practice, we'll typically drop the outermost parentheses of a sentence, unless a sentence is a component of another sentence. So instead of writing this, we'll write this. Instead of writing this, we'll write this. And instead of writing this, we'll write this. Okay, let's do a little exercise to test our knowledge. Using the rules of formation, say which of the following are SL sentences. You can pause the video and think about it. Okay, here we go. A is an SL formula, since it is formed by applying formation rule 2 to form tilde B, and then by rule 3 to form A ampersand tilde B. So it is permitted by our formation rules. Example B is not an SL sentence because it can't be formed by successive applications of our rules. There is no rule that allows you to put a tilde immediately after a sentence letter, for instance, as opposed to in front of it. Example C is an SL sentence, since it is built by using rule 2 and then using rule 4 twice. Example D is not an SL sentence, even though students sometimes mistake it for one. The problem is what comes after the ampersand. Remember that any application of rules 3 and 4 introduces both the connective and the parentheses. So when you introduce the V, you also enclose the resulting expression within parentheses. And you keep the parentheses if the sentence occurs within another sentence. Therefore, this is not a sentence because there is no sequence of rule applications in our system that generates it. By the way, note that our formation rules are designed in such a way that no sentence is ambiguous. That is, it ensures that every sentence can only have one interpretation. In contrast, if you wrote the string in D, the result would be ambiguous, and I wouldn't know what you meant. Did you mean the sentence to be a conjunction? In which case, C, V, D would be the right conjunct? Or did you intend it to be a disjunction? In which case, A or B ampersand C is the left conjunct? As it stands, the expression is uninterpretable. To make it interpretable, you would have to add parentheses. Okay, finally, example E isn't an SL sentence either, because the English word or does not appear in any of our formation rules, so there is no rule that introduces it. Valuation rules. Okay, we're done with the formation rules, but we're not completely done with the description of SL, since we still need to mention the valuation rules. The valuation rules have to do with the interpretation of the symbols of the system, in terms of the notions of truth and falsity. The valuation rules tells us for each of the connectives how the truth value of a given compound sentence depends on the truth values of its component sentences. So they basically give the same information as the truth tables for the connectives, but in a more compact way. In fact, the information they give can be extracted from the truth table definition of each connective. So the first rule is this. Tilde x is true if x is false, and false if x is true. The second is that x ampersand y, that is, a conjunction, is true if both x and y are both true. That is, if both conjuncts are true, and false otherwise. That is, it is false when at least one of the conjuncts is false. The third is that x v y, that is, a disjunction, is true if either x or y is true. That is, if either of the disjuncts is true, and false otherwise. Okay, let's do another exercise. Remember that our SL connectives are truth functional, and that entails that the truth value of any SL sentence can be determined from the truth values of the component sentences and the connectives involved. And indeed, this last sort of information is what is provided by the valuation rules of the connectives, or alternatively, by their associated truth table. Suppose A, B, C, and D are sentences with the following values. A and B are true, whereas C and D are false. Then, what is the truth value of each of the following sentences? Let's begin with A ampersand B. It is a conjunction whose conjuncts are A and B. Is it true or false? Well, we just need to know the values of the component sentences and the way in which the valuation rule of the conjunction works. The valuation rule says that a conjunction is true whenever both conjuncts are true, false otherwise. Now, A ampersand B is a conjunction whose conjuncts are A and B. And as we know, both conjuncts are true. Therefore, A ampersand B is true. We can also visualize this process with these two tables. The first one gives the values of the component sentences, in this case A and B. The second one is a truth table for the conjunction. Again, A and B are both true, and the case in which both conjuncts are true is shown in the first row of the conjunction for the truth table, so it yields true. So A ampersand B as a whole is true. What about 2? A ampersand C. In this case, A is true, but C is false. But the valuation rule tells us that a conjunction is true whenever both conjuncts are true and false otherwise. In this case, at least one of the conjuncts is not true, so the whole sentence is false. And the same information can be obtained from the truth table. Now to 3, which is B, V, C. B is true and C is false. The sentence is a disjunction, and the valuation rule for the disjunction tells us that it is true whenever at least one of the disjuncts is true. And in fact, one of the disjuncts is true, namely B. So BVC is true, and again, you can visualize it with the truth table. The last one is not C ampersand D. We know that both C and D are false, but what about the connectives? Well, we have two connectives, the ampersand and the tilde. This sentence is formed by conjoining C and D, and then negating the result of this conjunction. If we work from the inside out, we can follow these steps. C and D are both false, so by the valuation rule, C ampersand D is false as well. We know that the tilde inverts the truth value of the sentence it applies to. So given that C ampersand D is false, then not C ampersand D is true. Okay, that's all for today. Bye.